Hello class, in this lecture I will be talking about chi-square distribution for goodness of fit. So this symbol means chi, and because we have square we will call it as chi-square. So in this lecture I will be solving problems, hypothesis testing problem using chi-square distribution. So as we discussed, the first step of hypothesis testing is to define your hypothesis. So in chi-square distribution, the null hypothesis would be multinomial probabilities are P1, P2, so on, P of k, and the alternative would be at least one of the probabilities differ from P1, P2, so on, Pk. So what it means is, I will kind of give you an example. Our null hypothesis, if I say the probability of event 1 happening is 0.2, the probability of event 2 happening is 0.3, the probability of event 3 happening is 0.5, then our alternative would be at least one of the probabilities will differ. One of the probabilities will differ. So this means if probability 3 is other than 0.5, that means our null hypothesis is not true. So the second step of hypothesis testing would be to compare test statistic with critical value. So in chi-square distribution, the test statistic is represented by chi-square value. So this is chi-square value, which is given by summation of I ni minus ei whole square divided by ei. So this would be the ei would be the expected value, and the ni would be the actual value, and then this sign is summation. That means you are summing all of them, and then you compare this to the critical value. So the critical value you are comparing. So I'm saying when you are comparing, we kind of will say if this chi-square value is greater than chi-square alpha, where alpha is the significance level, and k minus 1, then you reject H null. Or the other way is you look at the p-value, and if p-value is less than alpha, you will do reject H null. So here this k is comes from the probabilities, how many probabilities you have. For example, here you have 3 probabilities, so your k here in this example would be 3. So that's how you are going to do chi-square problems, and finally you will make conclusion. So I will take an example problem and try to solve it using chi-square distribution for goodness of fit. So suppose I have a company which produces 4 brands of 4 different brands of shirts, suppose, and they say the probability of first brand being sold is 0.2, which is 20% chance. Probability of or the other way you can say 20% out of 100 produced will be sold will be the first brand. The second brand would be 0.35, the third brand would be 0.30, and the fourth brand is 0.15. So if this is given, this will be given. In hypothesis testing, the first step is to define your hypothesis. So our H null would be P1 is equal to 0.2, P2 is equal to 0.35, P3 is equal to 0.30, and P4 is equal to 0.15. And then the alternative would be at least one probability is different. So that is our hypothesis, and then they will give you again, they will give you a table. So they will give you the brand. So we have 4 brands, so brand, and then they will give you this is brand 1, brand 2, brand 3, and brand 4, and then they will give you actual sales, which is represented by Ni. When I say Ni, I takes 1, 2, 3, 4. So Ni, so the actual sales is 102, 121 for brand 2, and then 120 for brand 3, and 57 for brand 4. So if you see, this is the data given. So the next thing is you have to calculate the expected value. So for this formula, we wanted to use this formula chi-square to get test statistic value. So this data will be given. Once this data is given, I am going to use chi-square distribution formula. So the chi-square distribution formula is summation of I xi ni minus ei whole square divided by ei. So that is how you are going to use this formula. So this is the formula. So the first thing is I need to calculate the expected value of I. So the expected value formula is given by E is equal to NP. So P is the probabilities and then N is the total sales or total sample size. So to calculate E, so I will calculate EI here. So this is expected value, which is given by EI. Okay, so to calculate, the first thing is I need to get N. So I will do N here. N will be the sum of all these numbers. So if I add 102 plus 121 plus 120 plus 57, this is going to be 400. So E would be, so EI for the first one, what would be the expected value? That is what I'm calculating now. So I will use a different color. So EI, the expected value I wanted to, that is for first brand, it should be NP1. So that would be N is 400 multiplied by P1 is 0.2. So that is going to give me 80. So I will write here, so I will do 400 multiplied by probability, that is going to give me 80. So the next one, again I take 400 multiplied by the probability of this brand happening is 0.35, so that would be around 140. So the next would be, again I will take this 400 and multiply it with the third probability, which is 0.30. This is going to be 120. And finally the fourth one, 400 multiplied by 0.15 is its probability, so that is going to give me 60. So if you add these all, 180 plus 140 plus 120 and 160, that is also going to be 400. So this is, I need to have square here. So now I'm going to use, I have EI values, EI values are here, and then I have NI values. I can plug those values here in chi-square formula. So this is how you are going to calculate chi-square formula. So this is going to be NI for the first one, that's 102 minus 80 EI squared divided by, again EI is 80 and then plus, so I have summation sign, so I'm doing plus. Again I have NI, which is for the second one 121 minus 140 whole squared divided by 140 plus, again third one I have 120 minus 120 which is expected value divided by whole squared divided by 120, and then plus, I will write in next page for the fourth one 57 minus 60 whole squared divided by 60. So if you calculate this, you will get 8.779. that is my chi-square value. So the chi-squared value is 8.779. So the next step is to compare this chi-square. So this is my test statistic value. Now I am comparing it with critical value. So the critical value, the formula is x alpha k minus 1. So not x, it's chi. I'm sorry for that, chi alpha k minus 1, this is the degree of freedom. So suppose alpha is given as 0.05, so chi would be this is chi square, I have to compare it with. So chi square 0.05 k minus 1. So how many brands I have? I have 4 brands. So I will do 4 minus 1. So I am looking for chi square at 0.05. 4 minus 1 is equal to 3. That is the value I am looking for. So to look for chi square value, I will go to our canvas, go to modules, again go to calculation aids in module 0, and then download statistical tables. So now we have this, we are going to go to chi-square chart and then look for chi-square at 0.05. So that is our, let's look at what value they are asking us again. So let me, so chi-square 0.05 and degree of freedom 3. So I will go here and then chi-square 0.05 is this one and degree of freedom 3 is this one. So I will look at this value, which is 7.814. So I will write that. So this value is 7.814. So again I am saying if chi-square greater than chi-square alpha k minus 1, reject your null hypothesis. So here this chi-square is 8.779. This is greater than 7.814. Is this statement true? This is a true statement. 8.77 is greater than 7.81. So that means we are rejecting H null. So this is how, if we wanted to draw this and show you, this is how it looks. So a chi-square looks like this, and then we have our critical value, which is chi-square alpha k minus 1. So in this case it would be 7.814. so anything to the right of this point would be reject H null, and anything to the left of this area is do not reject your null hypothesis. So now you go and look for where is your this test statistic value on which region. So if you see 7.814, the 8.77 would be to the right of it. 8.779 will be somewhere here. So this will be in the rejection region. So that means the probabilities are not equal, they are different. So if I reject this, I'm rejecting this. So this is false. No, I'm rejecting this null hypothesis. So our alternative is inherently true. So that means at least one probability is different. So that is how you are going to solve this problem. So I will try to solve this problem using our calculation aids, and I will try to note down the values. So calculation aids. So the first thing we need to note down is our hypothesis. Our probabilities are so this is again I'm copying from here the given values. So these are the values, and so I will copy that. So I will go, I have it in a sheet of paper, so I will just copy that from there, so you guys can copy from the question itself. So the probabilities are P1 is 0.2, P2 is 0.35, P3 is 0.30, and P4 is 0.15, and then alternative is at least one is different, one probability is different. And then the data given would be brand. We have different brands, so I have brand 1, brand 2, brand 3, and then finally brand 4. So N would be 102, 121, 120, and 57. So this is the data will be given. So all the expected values and chi-square values we can chi-square and critical value we can get it from our calculation aids. So I will go to the calculation aid and key in these values. So again I'm going to Canvas, go to your modules page, and then in module 0 go to calculation aids and download chapter 15 calculation aids. So once you have this, the first one is the first tab you have to use in this, which is goodness of fit. So you have here goodness of fit, so you can use that tab. So first thing is they're asking you to enter the probabilities. So probability or belief means probability. So I'm going to copy these probabilities here. So our probabilities are 0.2, 0.35, 0.30, and 0.15. So our probabilities, I will copy that. So this is 0.2. So the next probability will be 0.35. So I have written these in a sheet of paper, so I will just copy from there. And then the next probability is 0.30, and finally the next probability would be 0.15. So now once we have these, we have to enter the actual values. So if you see this, we did probabilities, now we have to enter actual values. So the actual values would be the n. So this is actual values, so you have to copy this 102, 121, 121, and 57. So I will copy those values. So this is 102, then we have 121, 121, and then we have 120, and then finally 57. So if you see again, we have our expected values. We got expected values for each one of them: 80, 140, 120 and 60. Total is 40. And then our test statistic, we got it, and then we need to enter alpha value. Alpha is 0.05. So once I enter it, I get my critical value. The degree of freedom is 3. We are saying reject, and we have got p value. So again, we are looking at p value less than alpha. P value is 0.03. Is it less than 0.05? This is a true statement, so we will reject H null. So that's how you are going to solve these problems. So this concludes my lecture on chi-square distribution for goodness of fit.